Welcome back to episode 4 of our Flutter Sudoku series. In the last episode, we created our puzzle library with 4 awesome Sudoku puzzles. But here's the problem. If a player closes the app while playing, they lose all their progress. Not cool, right? Today we're fixing that by building a storage service that automatically saves and loads game progress. When players close the app and come back later, they'll pick up exactly where they left off. Let's dive in. We're going to work in the Services folder today. This is where we put code that handles external operations like storage, network requests, or database access. Clean separation of concerns. Let's open StorageService.dart. This file is currently empty, so we're building it from scratch. First, import SharedPreferences. This is the package we added way back in episode 1. It gives us simple key value storage that persists on the device. Think of it like a dictionary that survives app restarts. Next, Dart convert. This gives us JSON encode and JSON decode, the functions that convert our Dart objects to JSON strings and back. Remember all that to JSON and from JSON work we did in episode 2? This is where it pays off. And finally, we import our GameState model. We need this because we're going to be saving and loading GameState objects. Notice the import path, /models/GameState.dart. The 2 dots mean go up 1 level, from Services folder up to lib, then down into models. This relative import keeps our code organized. Now let's create our storage service class. This will be our single source of truth for all storage operations. Anytime we want to save or load game data, we'll go through this class. First thing, we need a key constant. SharedPreferences works like a dictionary. You store values with a key and retrieve them with the same key. I'm calling it GameState, simple and descriptive. Three important things here. First, it's static. We can access it without creating an instance of storage service. Second, it's const. The value never changes. Third, the underscore makes it private to this file only. No other file can accidentally use or change this key. Now let's write our save method. This is where the magic happens. Let's break this down. It's static. No need to instantiate the class. It returns future void. That means it's asynchronous, but doesn't return anything. We mark it async so we can use a wait inside, and it takes 1 parameter, the game state we want to save. First step. Get an instance of SharedPreferences. We use a wait because this is an async operation. It might take a moment to access the device storage. This gives us our handle to the storage system. Now, the actual save. Let me break this down from inside out. First, GameState to JSON. Remember that method we wrote in episode 2? It converts our GameState object into a map. Then, JSON encode takes that map and converts it to a JSON string. Finally, prefs.setString saves that string with our key, GameState. And we're done! The entire GameState is now safely stored on the device. Close the method. Just 3 lines of code to save the entire GameState. That's the power of good architecture. We did all the hard JSON work in episode 2, so now saving is trivial. So what actually happens when we call this method? On Android, SharedPreferences stores the data in an XML file in the app's private storage. On iOS, it uses user defaults which stores it in a plist file. On web, it uses local storage. The beauty is, we don't care. Flutter abstracts all of that behind one simple API. Write once, works everywhere. Now the reverse operation. Loading. This method is similar, but with one key difference. See that question mark after GameState? That means this method might return a GameState, or it might return null. Why? Because if there's no saved game or if something goes wrong, we can't return a GameState. Returning null tells the app, no saved game found, start fresh. Again, we get our SharedPreferences instance. Same as before. Now we try to get the string using our key. If nothing was ever saved, or if it was cleared, saved game will be null. That's okay, we'll handle that. We check if we actually got data. If saved game is null, we'll skip all this and return null at the end. If we have data, we wrap the conversion in a try-catch. Here's why. What if the saved data is corrupted? What if the user manually edited app files on a rooted device? What if we change the game state structure in an app update? Any of these could cause JSON decode, or from JSON to throw an error. We don't want to crash the app. Better to just start a new game. The conversion is the reverse of save. JSON decode converts the JSON string back to a map, then GameState from JSON converts that map back to a GameState object. Save and load are perfect mirrors. If anything goes wrong, corrupt data, format errors, whatever, we catch the exception and return null. This is graceful error handling. Instead of crashing, we just start a fresh game. The player might lose their progress, but the app stays stable. If saved game was null, meaning no data was found, we return null here. This tells the calling code no saved game exists, and that's our load method. It handles 3 scenarios: successful load, corrupted data, and no saved data, all with clean, simple code. One more method, clearGameState. This is useful for when the player completes a puzzle. We want to clear the saved data, so next time they open the app, it starts fresh instead of loading the completed puzzle. Get SharedPreferences, then call remove with our key. This deletes the saved game data. Simple as that. Now it's like no game was ever saved. Now our storage service is complete. Let's review what we built. 3 static methods: saveGameState, loadGameState, and clearGameState. Together, these give us complete control over game persistence. Save, load, and clear. That's all we need. And next, we start building the user interface. We'll create the Sudoku cell widget, the visual representation of a single cell in the grid. That's where we'll add colors, borders, highlighting, and make it tappable. It's going to look great, so if you find this project interesting, please hit that like, subscribe, and notification button. It really helps me to continue making more videos. Thank you for watching, and see you in the next episode. Happy coding!